threat in the Gulf, and more importantly, the flooding threat that is going to accompany it as it comes onshore, or whatever, even if it's not a named storm or a depression, even the moisture likely coming this way. Um, what you're seeing here is infrared satellite loop. You're wondering, what is this here? Well, that's a blow up convection that's outside of the where the low level circulation is that we were tracking off the east coast of Florida, moved onshore. And what I think is happening is this low level center is seems to on most of the models they seem to lose it for a little while and redevelop it over here and try to make like a really weak surface low in the next couple of days in this area. And I listened to Dr. Levi Cohen. He runs Trouble Tidbits, and he's has a doctorate and works at the Joint Typhoon Warning Center, and he did an analysis of this. And I think this is what's happening too. Is you have a low level center here, and a mid level center will probably keep going over the northern Gulf, and once it reaches more favorable environmental conditions, meaning less wind shear and higher mid-level dew-point temperatures, it may try to develop into a weak tropical depression, possibly a weak tropical storm, but I don't think any more than that's going to happen. That being said, let's take a look at some of the models output here. You have the EPS, which is the European ensembles. You can see all the members here. You can't even count how many they are. But if you go back in time to say, this initialized yesterday afternoon, valid like early this morning or late last night. You see here on the Gulf Coast, you don't see any members showing any significant pressure centers, right? But over time, see they pick it up again over here off the off the Gulf Coast, off the coast of Mississippi, Louisiana, eventually move it on shore just to the southwest of New Orleans. If you look at and remember the ensembles, or like the European has 51 members. So each one of those numbers represents the last two digits of what the expected pressure to be, and it represents a member, one of the members out of the 51. The more numbers that are there that are close to each other indicate a really good agreement, which you see right there. And with the low pressure center, so I can't see all the numbers there, but there's going to be a pretty weak low pressure center at that point, at least according to this model right now. But there's quite a few members that agree. So if you go to the GFS, which is the American model, which has 21 members, and go back in time here a little bit, it's kind of all over the place with low level centers. This nebulous low pressure area And finally, it really doesn't ever like develop a low center, and it has maybe 10 members there that agree that something might be there. Usually the GFS is more aggressive, and then maybe I think it's struggling because there's no rule of a center over the water right now, and it doesn't know what to do with it really. But um, and if you look at the super ensemble output, which I talked about every day too, these are three different ensembles put together into one big ensemble. Um, Again, some of the members are there and agree that something is going to come on shore. You see, it also, it has a kind of offshore Florida and moves it like, wait, excuse me, kind of this. I can't draw it this morning. Kind of this way. So anyway, that's the three global models. I wanted to show you why I think it's the mid-level center that's moving, going to be kind of the main player here, whether or not we get um, another low-level center to develop wherever that mid-level center is. A lot of times that can happen if convection develops around the mid-level center and you have some vorticity at the surface develop, and then you get a vertically coherent system. I want to show you the precip, um, some upper level wind shear here, that what drives it's upper level wind shear is too strong from one direction to the other. For example, let's see, right about here is where we are right now. You have our upper level high pressure system. This is the 700, 200 to 850 shear, which is between the highest levels and the pretty low level of the atmosphere. And if you have the reds, oranges, yellows, that means the shear is higher, which tears tropical systems apart, doesn't allow them to be vertically coherent. You can see there's a high pressure system right up here. It's kind of over top of where our incipient circulation might be. Oops. I need to go back. Sorry about that. I had went backwards in the runs here. You see the high pressure kind of moves. This is the super ensemble. Moves over top where our circulation might be. So that, in that respect, it's beneficial to, vertical coherence of the system as long as it stays underneath that high pressure. And stronger systems tend to develop a high pressure aloft, kind of help enhance that with their outflow. But in this case, this high pressure is kind of developing over top of it. The shear is quite light anyway. So if you look at the 200 mil wind, just by itself, it's kind of blowing out of the. So I decided to switch to this really nice map that shows the different levels of wind and the direction in the atmosphere. See an upper level high, low level high pressure. Whoops, excuse me. I'm really not feeling the greatest today for some reason. Anyway, low level high, you see the surface winds quite strong um, in our area of interest here. I can't draw on this, sorry. But you go to a little bit higher in the atmosphere, which is 1,000 millibars, which is pretty close to the surface. See about the same thing. And this is wind and speed. You see, there's a like an upper level. It's it's trying to depict some kind of low pressure here, which may be related to the. It's not having a closed low. It may not. It may be related to the um, low pressure that a surface low that was moving over land at 700 millibars, which is a little bit the same thing here. See if you go to 1,000, it's kind of maybe showing something there. Go to the surface. It's like a weak wave, not even close circulation. At the mid levels, the winds are quite strong right now, and over top of the top of where the circulation might be. And you can see at the upper levels at 200, there's interesting upper level high pressure different cells here with it looks like a little bit of upper level cell, which may be related to our system at the highest levels of the atmosphere. This is a really good depiction of the streamlines, and it helps kind of determine where stuff is. That being said, I want to show you this because it's important to understand how the winds drive these systems, and the lowest level winds, weak systems, like whatever this might be, is driven by the low level flow, which is this or 1,000 millibars. And if the wind speed between the low levels and upper levels is significantly different than one another, it causes wind shear. And tropical cyclones do not like to form with high wind shear environments. So when I talked about the high pressure really being over top of it, that is one factor that would is a positive factor for development of a system like this. Next, I'm going to go over the sea surface temps and in that area, which is another factor in possible development, and the mid-level moisture dew points, and that's another factor that we have to look at with systems that could potentially develop in the Gulf. Dew points, which is how moisture is measured in the mid levels, which is an important, very important part. And what the National Hurricane Center talks about a lot of times with humidity levels in the mid levels, if they're marginal or really dry, then systems don't tend to develop in those areas. You need relative humidity is pretty high because tropical cyclones are driven by, relative humidity is high dew points. Because tropical cyclones are driven by heat, latent heat release. And if you don't have moisture in the atmosphere, you can't get latent heat release. And it has to be deep, moist through the whole column, really, to really be effective in doing that. Contrast it with, say, a supercell on the continent of the United States. They tend to do better if you have some dry air at the mid levels because it creates deep lap breaks and things like that. Anyway, what this shows here is the relative humidity percent between 700 and 300 millibars was the middle part of the atmosphere. See, the brown is like lower numbers. You can see them over here. Green is higher numbers. And you can see there's a lot of dry air where the system might be. You kind of see over time, it kind of moistens up potentially as it moves on shore. It kind of brings a pocket of moisture right over that area we discussed, Louisiana, Mississippi, New Orleans. If I switch to the GFS model, it kind of has more of a broad moisture pocket movement on shore, which is, let's see, at the beginning of this, there's just a lot of dry air around. And it seems to moisten up some, at least where it is, over time. And it's a little more nebulous because it doesn't really develop as much of a focused high pressure as the um, European does. So there's three factors that we really consider with tropical development. Obviously, maybe four. You have to have a low-level center or tropical genesis. And we really don't have anything over water right now that would do that. And you have to have divergence aloft, which if you have a high-pressure system over top and light winds, that helps with that, depending on different flow to polar, which means flow that's outflow to the north. And so, mass can be evacuated away from the storm. And equatorward, if you have outflow, strong outflow both those ways, you have a higher potential for a storm to strengthen. And that can, with stronger cyclones, you can see that happen very quickly. You can have them strengthen very quickly if you have those factors. The sea surface temps and wind shear has to be favorable, so sea surface temps have to be at least 26 C, which is 80 degrees F, at least I think it's 50 meters down to maintain tropical cyclones. Sometimes you can get them developed a little less than that depending on environmental conditions aloft, but that's kind of the rule of thumb. So we've already looked at the dew points, the upper level wind and wind shear probabilities, which we established is not too favorable right now, but it looks like it become more favorable over time. And the dew points should become more favorable, and we'll look at the sea surface temps, which are pretty favorable, of course, and I'm trying to get to the right model that would show this. Yeah. So you can see this is one of the hurricane models that shows the sea surface temps, and it's like bathwater here in this area, right off the Gulf Coast. 30C, 31C, that's like 85, 86 Fahrenheit, almost close to 90. And so the heat in the tropical cyclones run off heat energy, which is in the form of latent heat release. So as long as you have sea surface temps that are favorable, that's a good sign for possible tropical development. So you can see it's there's no problem there along the Gulf Coast. As far as excessive rainfall, and I mean that's going to be a biggest threat. Biggest threat with this system for today, day one. Marginal risk along the Gulf Coast of Florida. High risk and a bunch of different slight risks in a bunch of different places over Pennsylvania, West Virginia, Virginia, Ohio, Upper Midwest, Great Lakes, Mississippi Valley to High Plains, and a marginal risk throughout on the outside of those areas. can see the risk moves further on shore. New Orleans, day 2, which is tomorrow. And we all know New Orleans is below sea level, so they are pretty prepared to handle, flood inundation as long as it's not super extreme. So I think they'll probably be okay, but we'll just have to see how it plays out. We still have a moderate risk just to the west of New Orleans and to Louisiana and parts of Texas for day 3, and up in Iowa, Nebraska, Midwest here, high plains, with some marginal risks in different areas. We move the slight risk a little bit further east as a result of that system, and we have another slight risk up in the Ohio Valley, on the Midwest, and the Great Lakes, marginal, broad marginal risk for a good portion of the country. Day 5, thankfully nothing in Texas, but we have another slight risk in the Ohio Valley and Illinois, Iowa, and the desert Southwest. So you can see by today's Wednesday, by Friday, we have a high risk of precip, excessive rainfall, which is exceeding flash flood guidance within 25 miles of a given location. So here's a precip forecast. Let's go for day 1. There, you saw that convection offshore. You can see right here, and this is your 40% risk of tropical development that the National Hurricane Center has put out in the next 2 to 7 days. It's going to be closer to 2 than 7, I think, at this point. And you move. This is the precip, daily precip totals. So 2, 3, 4, 5 inches right offshore here, or close to in some of the parishes here. We go day 2. Moves a little bit further inland, squarely over New Orleans, right offshore there. And day 3 is where it moves into Louisiana, Lake Charles, with a bullseye there of 3+ inches. I think as time goes on, this forecast will be more refined, but again, just because we have tropical development doesn't mean it won't, rain hard. You don't have to have a strong system for a lot of rain to fall, and typically weaker systems, especially ones that hang around a while, move on shore in this manner, tend to produce more flooding because they don't have some really good steering currents to move them out of there quickly. So hence the moderate risk for flooding. As far as future weather for today, and so today we have some convection ongoing in the upper Midwest, high plains, northern plains. And the higher, you can see this convection moving up into the Great Lakes, and some moving into the northeast. And this is tomorrow morning. This low pressure here kind of skirts the northern tier of the states. Look, there's a lot of moisture that's kind of trapped in the mid-Atlantic, and you see a broad swath of moisture, at least depicted by this model, along the Gulf Coast. But for the southeast, it looks like it's going to be at least quite dry. Not a lot of chances of rain in the next couple of days. Maybe some pop-up showers and thunderstorms. That's about it. I hope you enjoyed this video. I spent a lot of time on the tropics for a reason. And I hope you all have a great day.